Hey everybody, welcome to lesson number 5, complex numbers. This is the first lesson of complex numbers. This first lesson will be focusing on imaginary numbers themselves and how to simplify and identify them. And the second lesson, which will be lesson number 6, will work with addition, subtraction, multiplication of complex numbers. So let's start off with what complex numbers are. Right? They're actually two pieces, a real piece and an imaginary piece. And we're going to look at the imaginary parts right now. Okay? Imaginary numbers are the result of taking the root of a negative number. We denote that with an I for imaginary. I make mine cursive so it's easier to see and it doesn't get confused as a 1. Here you see the definition of I is the square root of -1. Very specific. So let's look at simplifying a couple of problems, right? If we take the square root of -25, this can actually be rewritten as the square root of -1 times 25, all under the radical. Now, because I know that the square root of -1 is just I, that root comes out no problem, and then I take the root of 25 out like usual. The root of 25 is 5. So we get 5i for that particular problem. Okay, another problem here, if I wanted to break this up, I would do -1, 25, and 5. 25 will come out, the root is 5. -1's root is I, and that 5 is trapped inside the radical. And we got one more example here. If I break this up into -1, 9, and 6, that would be 54. 9's root comes out as 3, -1 comes out as I, and that 6 is trapped inside the radical. So you got 2 for you to try right here. If you want to pause the video and resume when you're ready to check. Alright, let's see how you did with these. -1, 16, and 3 give us -48. 16's root is 4. -1's root is I, and that 3 trapped inside the radical. -1, 3, and 100 would have worked to get us -300. The root of 100 is 10. The root of -1 is I, and that 3 is stuck inside the radical. Okay, pretty easy to simplify. Hopefully you got those ones all right. Now let's look at some other pretty cool things that have to do with I. Pretty cool if you're a math nerd like me. So let's take a look at this. We already know I to the first is the square root of -1. Well, if we were to do I squared, that's really saying I times I, which is the same thing as -1 times the root of -1, which is really just the root of -1 squared. And what happens with squares and square roots? They cancel, and we're left with whatever that radicand is. Happens to be -1. So what's really cool here is that we went from an imaginary number, I squared, and we ended up having it be an actual real number. Right? We're taking two different planes of existence here, and they end up being the same thing. It's kind of cool. I to the third. Well, that's really just I times I squared, right? Well, that would really just be the square root of -1 times -1, which is really negative root -1. And for I to the fourth, we could do I squared times I squared, which is really just -1 times -1, which gives us +1. So again, pretty neat. We have in these 4 here an imaginary real. But it gets even cooler than that. Okay, I to the 5th. We can think of I to the 5th as, let's say, I squared and I to the 3rd. I squared is -1. I to the 3rd is negative root -1. Double negatives will cancel out. That's just root -1, which is I to the 1st. So I to the 5th and I to the 1st are the same thing. Alright, how about I to the 6th? If I was to do I squared and I to the fourth. That's I to the sixth. I squared is negative 1. I to the fourth is positive 1, which gives us negative 1. Hey, look at that. It's the same thing as I to the second. I to the seventh. We can break the I to the third and I to the fourth. Let's see, negative root negative 1 times positive 1. Hey, that's not going to change. Negative root negative 1, which is the same as I to the third. I to the eighth can be broken down to I to the fourth and I to the fourth, which is really 1 times 1, which is 1. So now check that out. As I went across here, they matched. And I went across here, they matched. They matched. They matched. Let's try one more to see if that works. I to the ninth. Well, that's kind of like I to the eighth and I to the first. I to the eighth is really just 1 times root negative 1. So that just gives us back I again. Right? All of these across the top give us I. I'm willing to bet that this next one will give us negative 1. Let's try it. If I were to do I to the fifth and I to the fifth, that's just I times I, which is I squared, which we just found out to be negative 1. So that matches. So we can predict this next one will be negative root negative 1. And we can predict our last one here will be positive 1. In fact, this is, as cool as it is, not something that just randomly shows up. This makes sense based off of the fact that we have quadratics, right? Multiplication of a positive and a negative, and how square roots work. So it makes sense that we would see repetitive things show up like this. It's cyclical. In fact, what's kind of cool is that somebody came up with these power rules of I for us. So here's how this works. You want to write this down. Okay, the I power rules. If we divide the exponent or the power on I by 4, remember there were 4 categories that we saw, and then look at the remainder. If we have a remainder of 1 or 0.25 in the calculator, it behaves as I to the first, and this is what it's equal to. Remainder of 2 or 0.5 acts like I to the second, which is equal to negative 1. Remainder of 3 or 0.75 acts like I to the third. We can write either one of these depending on what they ask us for in the instructions. And then finally we have no remainder, right? 4 divided by 4 or 8 divided by 4, 12 divided by 4, those all give us no remainder. So we'd have 0.0 on the calculator. Acts like I to the fourth, which is equal to 1. So we're going to do a couple of these problems. You're going to need a calculator handy. So if you want to grab one of those real quick, I've got mine right here. Alright, so here's what we're going to do. We're going to take whatever number that they give us here to 13 and divide it by 4. That's 53.25. I'm looking at that 0.25. I'm matching it with my list up here. It says it acts like I to the first, which is the square root of negative 1. Okay, that's evaluating. We'll do the same thing with this 38. Okay, 38 divided by 4 is 9.5. Then I look at the 0.5, acts like I squared, which is negative 1. 127 divided by 4 is 31.75. We look at the 0.75, acts like I to the third. We can write either one of these. It doesn't matter to me. We'll do negative I for this one. So you got 2 here to try on your own. Okay, 19 and 328 are your powers there. Pause the video and resume when you're ready to check those. Alright, let's see how you did. 19 divided by 4 is 4.75. 0.75 matches with I to the third, which is negative I. 328 divided by 4. That's 82. No remainder, so 0.0. That acts like I to the fourth, which is equal to 1. Alright, a couple more things to go over here. Okay, multiplication. Multiplication is going to work just like would multiplying regular variables. Remember, I is a variable, right? It takes place of -1 for us. So when we multiply like x times x, we would get x squared. It's going to be the same thing if we do I times I. It will give us I squared. So we're going to multiply like usual here. 3 and -6 gives us -18. I times I is going to give us I squared. Now the only thing that's different about these particular variables is we know what I is versus like a normal problem we wouldn't know what x is. But I know I to the second. I know I to the second is really -1 in disguise. So I can do that multiplication and I can get a simplified answer of +18. Check out this one. 4 times 6, that gives us 24. I squared times I to the first is I to the third. I know what I to the third is. It's -√(-1). So our final answer here would be -24 times √(-1). Or you could write it as -24i. That's fine too. Let's see, -4 and -7 is +28. I times I is I squared. Again, that I squared is really a -1. 28 times -1 is -28. These ones a little more difficult because we have to put them into that I form, the imaginary form. They're technically imaginary right now, but we want to see the I to make it a little bit easier for us, right? So I'm going to break this up. -1, 4, and 5, and -1 times 9. 2i √5 is how that first part simplifies, and 3i for that second part. 2 times 3 is 6, I squared, and that √5 kind of tags along. I squared we know is -1, so this -1 times 6 is really -6 √5. Okay, so you have a couple to try up here. 3 of them, so if you want to pause the video and resume when you're ready to check those 3, we'll do them all at once. Alright, let's see how you did here. 7 and -2 is -14. I times I gives you I squared. You should have recognized I squared as -1, which will give you a result of +14. Your second problem, 2 times 6 is 12. I to the third, I to the first gives you I to the fourth. I to the fourth is really +1, so your answer here stays as +12. And finally, up here we have -1, 9, and 2 is how we can break up 18. -1, 25 for that second piece. The roots here will be 3i, and √2 will stay. And over here our root will be 5i. Okay, make sure that you were able to simplify those radicals. And then finally we can do our multiplication. 3 and 5 gives us 15. I and I would be I squared times √2. This is really a -1, so we get -15 √2. Alrighty. Got 3 more problems to look at. Sometimes they ask us to solve. Now, this is not the quadratic equation like we've seen before because we don't have a b term here, right? There's no x to the first. So when we solve these particular problems, we're going to just solve it algebraically, isolate x however we need to. So for this first problem, 7x squared plus 28 equals 0, I'm going to isolate x first by subtracting 28. Then I'll divide by 7. And then last, we'll take the root. Now, when we're solving for x, something different is going to happen here. When I take the root from now on, it's always going to give me a plus or a minus. That's because technically I don't know if it's a positive or a negative number that I'm squaring to get the number inside. So I want to make sure I cover both situations. Let's see, the root of 4 is 2, and then that -1 becomes an I. So our solution here is plus or minus 2i. Same idea here. 3x squared plus 75 equals 0. I'm going to subtract 75 from both sides. Then I'm going to divide by 3. X squared equals -25, and then we'll take the root on both sides. Remember, we want plus or minus. The root of 25 is 5, and then we have I. So there's one more problem for you to try out right here. If you want to pause the video and resume when you're ready to check your answers. Alright, let's try this one last problem. We'll start off by subtracting 800 from both sides. And we'll divide by 8. Take the square root on both sides. Remember, you want plus or minus. The root of 100 is 10, and then I comes out with it. So you should have gotten plus or minus 10i. That's it for this lesson. The next lesson we're going to look at, we'll work with adding, subtracting, and multiplying complex numbers. So far these have been imaginary. Pretty soon we'll start adding in real numbers to this as well. See you at the next video.